so real quick, our goal is going to be to implement this function. And this function is trying to do a crazy thing in blockchain. If you read the description, what we want is if a user calls this, we want to emit an event to a different blockchain entirely. This is not something that you can do in normal Solidity. But this is what we're going to try to do. This is the whole goal of today's workshop. Make sense? So here's a first attempt. One way you could do this is you just emit an event on the same blockchain, and then you have an off-chain process watch for that event. So you just write a little script in Bash or something, watches the blockchain, watches for the event, and then goes and does the action on the other blockchain. So it goes, submits something to the other blockchain, and causes an event to be emitted. You call that your Hello Wormhole app, and you said, I implemented the function. It requires you to have write a script. We don't want to do that, but this solution makes us write a script. It's not stored in the blockchain, but we could have the off-chain script call the blockchain, which then stores it. Like we could, if you look at the receive function, we can update the state in the receiving blockchain. So we could get that. This is how an arbitrary wormhole app at its core works. You have a source chain that sends a message. 19 organizations watch for the message, sign it. And then there's an off-chain script that takes those, that packet of data with the 13 of 19 signatures, quorum, two-thirds quorum, and brings it to a contract on the target chain, which then the contract can verify the signatures and do whatever it wants. This is what's happening under the hood in a wormhole application. You have a sending thing. You then send a message. It gets signed by 13 entities, and then it gets brought to the target chain. What's your name again, by the way? Ben. Ben just mentioned that we don't want to write this off-chain script. We still had the off-chain script in the previous slide. So what we did, we recently launched this new feature that we're calling automatic relaying. This removes that script entirely. What it does is we provide you this interface, send payload to EVM, which lets you request the publishing of a message and its delivery to a certain address. And how it works under the hood, Joe will talk about later. But basically, the message gets published and instructions are published on where to bring it. It gets signed and then brought to the correct location. And at that location, the signatures are checked. And then it gets sent to your target address, which has to implement this interface right here, the receive wormhole messages function, the iWormhole receiver message, the iWormhole receiver interface. So two things you have to do. Send the message and receive it, implement the receiver interface. That's all you have to do. Everything else happens under the hood seamlessly. And that's what we're going to do today. Any questions here?
What's the delivery hash?
Delivery address? Delivery hash, yes. In receive wormhole messages, every delivery happens with, we provide you the hash of that piece of data that gets published on the source chain. It's just, it's not the transaction hash, it's, yeah, the hash by wormhole itself, yes. And it's useful if you want to prevent duplicates from arriving.
Yes, hello. How do you identify the target chain and the source chain? Is that a special code that Wormhole has implemented or something like that?
Yes, exactly. That's a great point. Target chain, these are all details that are in the interface file itself, but it's a number that corresponds to the chain. For example, Avalanche is 6, Celo is 14, Ethereum is 2. There's different codes. What our goal is to, or how we're going to do it is we implement the send thing. This is for the whole workshop. We want to send a payload on the source chain by calling this function, send payload to EVM. what happens under the hood is a message gets published, as well as instructions on how to deliver the message. And then it gets signed by the 13 entities. It gets brought to the specified target contract, which implements the iWormhole receiver interface, the second thing right here. And that's what we did in this step. So back to the code. The first thing is to remember that the off-chain script calls a contract, which is what we call the wormhole relayer contract, that then calls this contract. So the message.sender here needs to be the wormhole relayer contract, which we have as a state variable right here. The reason why we want to require this, I'll just write that line of code real quick. The reason for this is we don't want any other users calling this endpoint because they can call this and make up payloads. There's no other checking we have here. Crucially, this wormhole relayer contract verifies the signatures of the 13 entities before calling this function. So we want it to go through this contract. So I add this line here. And then what we're going to do is we're going to call this function with the payload being all the information we wanted to send. And in this case, this comment indicates that it is the greeting and then the sender of the greeting on the source chain. So if you guys don't know what ABI.encode is, it takes a bunch of Solidity variables and just puts them together. And we're going to decode them right now. So get the greeting, get the sender, tell it what types it is. And that's all the wormhole part there is to it. Now we have the variables. We just write pure Solidity. So we're just setting a state variable, and we emit an event. And we do that. We can then test our code. Forge test. And it passes. We wrote the receive end, but now we have to write the send end of this. We need to actually get the payload to be sent so that the off-chain script can call receive wormhole messages, or call the wormhole relayer contract, which then calls receive wormhole messages. So that's step 2. Basically, all you have to do is run these commands, and then they're also down in the corner right now if you need to see them. Git stash, git checkout wormhole step 1. But step 2 is just you in this branch you have starter code for you have 2 empty functions that you have to fill in, and in those functions you have to use the interface, the iWormhole relayer interface, to get your payload sent in the way you want. If you look at the code, there were 2 functions, send cross-chain greeting and quote cross-chain greeting. How I would implement it is there's a function on the iWormhole relayer interface called send payload to EVM. All you have to do is call that with the appropriate inputs. The first input is target chain, which chain you want to send your message to. The next one is the address, target address. That is one of the parameters here, so we just use that. The next one is receiver value. What this is it's a feature that lets you request additional currency be brought along to the target chain and passed in as message value to the target chain. This is a feature that we do not need for this, but it might be a feature that you might want to use. But we'll just have that be 0. The next parameter in this function is gas limit. What's happening is we're requesting this off-chain process to call things on the target chain, but it needs to pay for it. It needs to pay gas. And it wouldn't be sustainable to have it just pay it out of pocket. Otherwise, no one would be one of these off-chain relayers. So we pass in an amount that constitutes payment, and this allows the off-chain relayer to fund their gas. To get the amount of payment we need to do, there's a nice line of explainer in the interface file. So if you control click on the iWormhole relayer interface in your code, you can see exactly what needs to be passed in as payment. And that can go into the implementation of quote cross-chain greeting. But basically, all it is call send payload to EVM with the correct inputs, and then it should work. Any questions about that?
Can you abstract the gas payment to another smart contract?
Gas payment to another smart contract? Can you?
Yes, take for example, so the relayer is making the final gas payment.
Yes.
Is that correct?
Yes.
Yeah. So if I don't want the relayer to make it, can I abstract it to another smart contract to make the gas payment?
I think what you're asking is, we have our internal automatic relayer thing that has relayers do the payment. If you want to do your own thing in your own way, you can absolutely do that. That's actually how people wrote wormhole integrations in the past. They just wrote their own process to call the target chain. That is very possible. You can write your own off-chain process, on-chain process, anything. It's just more difficult. But we offer this nice way of doing things where you don't need to do that. You can use our defaults. But if you don't specify anything, it goes to the default relayer. But you can specify any relayer, and they will do it. So if you opt into the defaults, it is centralized. But crucially, the trust assumption of correctness is not centralized. So the guardians are still a decentralized network of 19 entities. That is always true for anything wormhole. It's just the liveness of the relaying that is centralized if you opt into the defaults. Great question. Any other questions? After this step, you can feel free to look at the main branch. There's nice instructions in the README for once you have your thing working, you can immediately deploy it and test it on testnet by running 2 simple commands. And that's it. That's all it is to a full wormhole integration. You could call it a day and be done with the hackathon after these 2 steps, and because you literally made a wormhole integration. We also have extensions if you're interested in other things you can do, or things you can do to improve your current implementation of Hello Wormhole. We have a bunch of extensions that you can reach on this tiny URL right here. etc wormhole extensions. We'll mention this later as well. Feel free to ask us for the link.